All right, last video of this chapter. I had asked you to do exercises 33 and 35 out of the book. Hopefully you were able to do them, took a look at the answers already. Guys, let's talk very quickly about one-sided limits. We've already talked briefly about them in my intro to limits, but I want to introduce some more vocabulary and do some examples. A right-handed limit is the limit as x approaches some number from above, from the right. A left-handed limit is the limit as x approaches some number from below, from the left. Notice approaching from the positive side and approaching from the negative side, from the right, from the left. Okay, so I want to look at a particular function, and the function we're going to look at right now for this example is called the floor function, INTX. It rounds down to the nearest whole number. It is very useful when you need a whole number of something. How many buses do you need to take people to a football game? You will need a whole number of buses. So it always rounds down to the nearest whole number. So when I look at this, the limit as x approaches 3 from the right, well, as x approaches 3 from the right, coming from up here, this is going to be equal to 3 because I'm rounding down. The limit as x approaches 3 from the left of this function, here I am approaching 3 from the left. Oh, notice that it is a completely different value. It doesn't matter what happens at 3, what happens as I'm approaching 3. This one will be 2, no matter how close I get to 3, because I'm never going to get to 3. This one will be 3, no matter how close I get to 3, because I'm never going to actually get to 3. All right, so here's what I want you to do. I want you to take a look at example number 8. Example number 8 has a graph that looks like this. This is on page 64. There are a whole variety of points that you can find limits at, or at which you can find limits if we're going to be grammatically correct. And if you look at this, you'll see that we can have limits at x approaches 0 from above. We can have x approaches 1 from below and x approaches 1 from above. We can have x approaches 2 from below and x approaches 2 from above. We can have x approaches 3 from below and x approaches 3 from above, and we can have x approaches 4 from below. The function isn't defined outside of 0 to 4, so we can't have approaches 0 from below or approaches 4 from above. I'd like you to look at example 8 and look at the what you see for each of these limits. Actually, in fact, why don't you pause the video and see if you can figure out what the limits are equal to for each of those 1, 2, 3, 4, 5, 6, 7, 8 things. I'm going to go ahead and erase the A. Okay, when you've done that, go back and take a look at example 8 again. And then I want you to do exercise 43. We are going to skip the squeeze theorem. So if you're interested, you can read it, but it is not part of the AP curriculum.